has used that red chair today. So, and yes, absolutely, that is there for you. You want this. Except I don't know why I'm ridiculously zoomed. Now, here's the issue with me not having recorded on Friday. I'm not sure if we... Oh, thank you so much. Adam, I did not get to grade this yet, so I will try to later, but if nothing else, I'll get them back to you guys on Thursday. I can't remember if we started distance formula or not. So I couldn't remember if I showed you guys these notes. I love that you just said that. So you're right. That is a distance formula. That's not the distance formula that we are talking about. So you're not wrong. That's a formula that we use for distance. What we are about to talk about is the formula that we use to find the distance between 2 points on a coordinate plane. So what Adam was just talking about is what I nicknamed the DIRT formula, which is that distance equals rate times time. So if you think about E as equals, but it's not like a variable E, just distance equals rate times time, or just D equals RT and just make up the sound in the middle. So that's another distance formula, but that's not what we're talking about here. So I want you to take a moment and look at that graph where it says below. So you want to be looking at the notes that say distance formula, by the way, not the volume practice. We'll get to that. We will get to that, I promise. Notice all my manipulatives up here. We will get to volume. Man, I think whoever set this graph up was kind of silly. Because what they had was 2 lines. And what they did was add an x and a y coordinate. Those aren't your notes. These are your notes. They added an x and y axes. But now this has an xy point and this has an xy point, and we need to find this diagonal distance. So, I mean, man, what things could we do that would make this easier? What do you think, Mike? Okay. Make this into a triangle by drawing 2 sides. I like it. So, like, I'm guessing you're talking make this into a right triangle. Okay. I still think this could be easier. Kelly? I like your crew hat, by the way. What? Alright, everyone take like a good 20 or 30 seconds. Just be in your brain. How could this, like, we were given just 2 points floating out in space. We created these axes. How could we have actually make this easier? Hang on to it for a second. I will come to you in like 20 seconds. If you want to ask yourself a different question, why isn't this as easy as it can be? Right? Like, why is Hudson trying to force us to Sorry, and I think I called you Maya. I know you're Rachel. My brain is messed up today. Oh, which reminds me, I forgot to announce this. I got shot 2 yesterday. Woohoo! But I don't feel great today. So I'm just trying not to tap out and go home. So I knew that you guys would be fine. Your class is always awesome. I could probably throw the pen at like any of you and just say teach. But I'm trying not to tap out. So if I do something dumb, just bear with me. Like I just called Rachel Maya. So anyone got an idea? Kelly, Nick, I saw some hands moving. Adam, I'm coming to you first though. Ooh, okay, yeah. I think that in my brain, that actually adds a little bit more complexity, like by adding in more stuff. You're not wrong. Like we could do that, and I think it would work. Were there more notes out here, guys?
Hopefully no one's asking. I'm about to write on all of these.
Guys, anytime you are asked to do something in math, there's normally an easiest option and a not wrong option, but not the easiest. Why wouldn't we just make the y-axis right here? And why wouldn't we just make the x-axis right here? No, but we are making the coordinate. Right? We are establishing where things go. So if we could make these our axes, then whatever this x value is the length of your leg. And whatever this y value of the point is the length of this leg. But life ain't always nice. So, since life ain't always nice, we can't always force those axes to be right there. So, we normally have what we call x1, y1, and x2, y2. So what we're searching for is the distance of the x side and the distance of the y side, which we know distance has a synonym that starts with the same letter. How do we find the distance between two things? We find the difference. So the delta x would be the ending x point minus the starting x point. And the delta y, right, same thing with that. It's the ending y point and the starting y point. So what we want to do is find the differences to act like this is our 0, 0 point, right? And we can just measure this and measure that. But because life ain't always nice, we have to do the extra step. Now, if we've been allowed to set this up, we know that the horizontal and the vertical form a right angle, meaning that this diagonal, well, that's really like our what? Yeah, it's our hypotenuse. It's the hypotenuse. Hypotenuse. Hypotenuse, too, if you want to say it even weirder. So we could say that d squared will equal the delta x squared plus the delta y squared. Right, are we all still with me on why we're allowed to say that? Because we already are comfortable with Pythagorean theorem. Adam? Because that's Pythagorean theorem, right? Hold on. I got a question for you. Is there any other way for us to figure out this? Now, assuming we cannot just measure it by knowing the x and the y lengths here. The only way I know is Pythagorean theorem. So, I mean, if you have another way, hit me with it. So that's why we're doing squared. Right, so this is c squared equals a squared plus b squared. This is, if I flip it around and write it the other direction, a squared plus b squared equals c squared, right? This is the Pythagorean theorem. Oh, I'm going to make it even more annoying, just for you, Adam. So, d squared, no, it's for all of us, don't worry. So now if I actually talk about, well, what is delta x, we can't just say delta x because no one's just going to hand us delta x because the world is not a, peachy, furry, like smiley, sunshiny place. Sometimes you got to do some math. So we said this is x2 minus x1 actually squared. And this is y2 minus y1 squared. And then because we want a formula that actually just tells us D, we're going to take the square root of x2 minus x1. Remember, these are subscripts, so they just denote which one they are. It's like thing 1 and thing 2. They just denote which thing they are. Guys, and we, you brilliant mathematicians, we just derived the distance formula. Guys, some mathematician wanted to say they had made some thing, so they stole Pythagorean's theorem, and they were just like, look at this thing I made, and everyone was like, no, it's the Pythagorean theorem, bro. And they're like, no, it's the way you can find distance between any 2 points. It's the Pythagorean theorem, bro. So now I'm making this up. This just makes it sound funner than it is. But for real, you can't just steal somebody's theorem and use different letters and call it something different. Now, Pythagoras, though, they maybe weren't working with points on the x and y coordinate plane. They were maybe just working with physical, tangible geometry, like this thing that I'm going to, dump around here later and probably make some of you nervous, and probably get some of my papers wet again. Adam? Have you ever heard of Deja Vu?
Yes.
Do you ever think that you actually already know about it because you actually already learned about it in a previous life? I don't know what your religious beliefs are, and I'm not putting any beliefs on anyone, but if you believe in reincarnation, there is this idea that our souls come back around and keep kind of getting put into new bodies. And some people will be like, I feel like I've been here before. I feel like I've done this before. And they think it's because of reincarnation. I think you're just smart. Yeah, I think you're just smart is what it is. So if we come down here, the world gets a tad bit nicer again. And if we're on a coordinate grid, do I need to write out that this is don't do this. Do I need to write out that this is 4, 2? And do I need to do the subtractions? No. Don't make the world a bad place. Well, yeah, not only do I not need to do that math, but this is a Pythagorean triple. Guys, it's because I make these notes and I'm not just trying to be a jerk. So on the next 2, turn them into a triangle. And if you need to do the Pythagorean theorem, do so. Because, guys, we don't have to use the distance formula. It's just another tool. If we can use the Pythagorean, because remember, it's kind of like this is stolen from the Pythagorean, but it's not exactly the same. If we can use the Pythagorean, use it. Yeah, anytime you have a leg of 1. Guys, I enjoy having you here because even though I don't feel great today, I don't know if you ever heard the phrase fake it till you make it. But when I at least get to teach you guys and interact with young people, I can forget that I feel crummy. Now, once I stop teaching, I'm going to hit a brick wall and feel like crap. But that's okay because it's just because somebody stabbed me yesterday.
That sounded like what? That sounded so bad.
That's my fun way of saying it.
Okay, because someone stabbed you.
I'm supposed to feel crummy because someone stabbed me yesterday. So that was my fun way of saying I got my second shot yesterday. What do we owe the pleasure of both of you here? What? This is like the Calvary.
There was an eval scheduled at 3.
I don't know why there was because I have a class.
Yeah, I know, that's what I was checking.
First
Yeah,
I wondered
it's-
if you were here.
Oh, yeah, I'm here.
like,
I can't do
even though
be
you got
2 places
stabbed,
at once.
Even though you got
You're
stabbed.
Well,
Actually, it was a fireman who stabbed me. So if anyone,
I
a
was
very
stabbed-
nice
I was
fireman.
stabbed by an EMS worker. Yeah.
Actually, the fireman who gave me my shot yesterday said he was chatting earlier in the day with a couple that had been married, not just alive, but married 74 years.
Dang.
And then he commented 4 years was long enough for him. And he had gotten out. I was like, oh my gosh, man. Well, now you guys threw me all off. Can I keep teaching or what's going on? I can. That's not awkward or anything. So, Kelly. See ya. Kelly, what'd you get for our value of this diagonal? Okay. 65 squared?
65 squared.
Ah, the square root of 65. I don't know if that's an energy boost.
More like something that'll give you a sugar high and then make you crash.
I was about to say, it sounds like a diabetic problem waiting to happen.
Yeah, like really.
I mean, my brother is diabetic, and when I hear something like that, it just sounds like... Alright, guys, finish up your Dairy Queen talk. Nick, what was our leg down here?
That was 4.
And our leg vertical? And this diagonal?
Square root of 97.
Square root of, we would do 9 squared plus 4 squared. I'm just writing out the steps for anyone who was...
97, because 81 plus 16 is 97.
Absolutely. Now remember, if they're not nice, we leave them be.
They're not nice to us. But it's in the middle of, obviously, 10 and 9 squared.
Excuse me. Now down here, to push even more that we don't need the distance formula, we couldn't even use it here. We couldn't even use the distance formula unless we created some axes and created some points, which we don't need to. So I'm trying to make sure that after we look at like the complicated way to solve, we remember a lot of times there's the easier way still. A lot of times there is the easier way still. So solve these really quickly, and then I'm just going to show you the answers. We're not going to take too much time to talk about these because we want to do some volume stuff today. But what if this is going to be scaled up to a different scaling? Did I show you guys the blueprints last week of my friend's house? But you can't just like measure something in the blueprint, because if I click my mouse, it changes what the measurement would actually be. Right? So you actually have to know the scale. If you've got them and you want to flip to the back, you can. Then you can come back and check these with me. Hey, look, I'm a nice guy and I gave you the distance formula. Print it out on your paper. So to double check your front ones, just before we move on, we should get radical 136, which our class talked about. How we would get down to simplified radical form. So if you were doing this in your calculator and it gives you 2 radical 34, remember these are exactly the same. So we talked really quickly because we don't need to master this yet, right? We don't need to do this. But we talked last week really quickly about how we get to simplified radical form. This, I should stop using such slippery sheet protectors. Oh my gosh. It's like Fort Knox up in here. This would become square root of 4 times 34. And we can do square root of 4. That's 2. We can't do square root of 34, so it stays. Right? This is how we make that jump. Our second one is square root of 61. There's no nice way to look at that as a simplified radical. Because even if we think about all the factors of 61, well, there aren't very many. And then we've got another Pythagorean triple. Flipping to the back, we actually have to apply our distance formula now. So yeah, the world gets kind of poopy. Take a couple minutes to apply your distance formula and practice that. I will show you the first one done out in both ways in a moment. You're like, wait, done out in both ways? Done out in both ways? So x1, y1, and x2, y2. What are you pointing at? Oh, well, also, I don't know that I make it any better to try to concentrate. I have a pretty, like, all over the place sort of demeanor. So, guys, it doesn't matter which point you make point 1 and which point you make point 2. I'm going to say that again. It doesn't matter which point you make point 1 and which point you make point 2, as long as you keep it the same for both subtractions. So if you do, can look at the board for a second, please. If you do 4 minus 2, you got to do 7 minus 2, not 2 minus 7, right? So if I start with my point that is up here and minus the point that is down here, I have to do the same thing here. But if I start at the point that is 2 and do 2 minus 4, and then again start with the point that has the 2's and do 2 minus 7, it mathematically comes out to be the same thing. Because when we square that negative distance, well, it's not a negative distance. It's just a distance the negative direction. So squaring fixes that, right? Squaring will fix that negative. Kelly?
Also, if you want the visual one, what I do is I draw a rectangle, and then I take the distance between 4 and 2, and I put it on one side, and I take the distance between 7 and 2, and I put it on the other, and then I use the Pythagorean Theorem.
So what you're saying, again, I could just throw the pen at you guys and say go ahead and teach, is if you visualize a triangle in your head and say, well, what would be the distance from -6 to -8? That's 2. Positive, negative doesn't matter. Remember, distance is always positive. What's the distance between my y's? How far is it between 4 and 6? Well, that's also 2. So then I should have written out this middle step.
Good afternoon, Phoenix. Please pardon the interruption. At the end of the class, could I please see Maya Landers and Kaylin Young in the office? Again, Maya Landers and Kaylin Young, please stop by the office at the end of the class. Also, for any of our students leaving for the first time on the athletic shuttle today,
She's making these announcements real early.
please be prompt at the end of the period. The athletic shuttle will depart at the end of 3B. You will need to take a moment to sign out on the clipboard each day before
I
going
can't
out
hear
to
you,
the shuttle.
so hold on.
For our students headed to the tour for Wolves Athletic, we'll be looking for bus number 89. And for our students that are Cardinal athletes headed for the Working Way and Kilbourne Middle School track, you'll be looking for bus number 18. Thank you.
I said it makes sense that she's doing it now because she said the athletic shuttle leaves at the end of 3B.
Yeah, I don't know what the deal with that is, like why they changed the schedule. So I think if you're an athlete, you need to leave class like a couple minutes early, just by the way. So do we have athletes here that need to leave for the shuttle? Sweet. I'm a mathlete, not an athlete, so it's okay. Question, Adam? Ooh, that to me starts to feel late, though. Guys, negatives create trapdoors. Negatives create trapdoors because when we do minus a negative, it's actually addition. So you could use the Kelly method that he was talking about of just think about the distance on the x and the distance on the y. And those distances would actually be 7 and 4. But with the math that I wrote down, I got -7 and -4. We, because we're smart people, know that that's not true. It's actually 7 and 4. But mathematically, we just want to keep this to like mathematically reflect what we wrote. Then the squares fix it, right? The squares fix that, make them positive again. So we get 49 and 16, right? Sorry, that's a 49 and that's a 16. And we add them up and get radical 65. Are there questions? on our distance formula at this point before you do that final one down there. Now make sure you've done that fourth one on your own. And then we are going to play with some water.
Water time.
Now you can't actually play with it because thanks COVID. But I can play with it and probably make a mess in the meantime.
Falling trips and dumps water all over the place on accident.
All I heard was falls and trips and dumps water all over Nick.
Thank you. I would appreciate that.
I mean, if you're that good, could be less accidents.
Yeah.
Accidents happen. Especially
Huh?
For what it's worth, I am recording this class today, so just talking about creepy things 7th graders say.
No, not really. I'm just being
It's like some weird version of Saw.
sure.
So, I realized yesterday that this 100% wouldn't work if I was filming on anything that like I couldn't point at my volume stuff. Actually, I know how we're gonna make this work. I'm brilliant. What a problem solver, guys. We're gonna do this. Switch the camera. Haha!
Good job.
Alright.
Hello there.
Whoa.
Woo!
And then this will create the infinite tunnel.
Oh my gosh, no. Not the infinite tunnel.
Zoom in.
Oh,
Oh no, where'd it go? Oh no, maybe it doesn't like the. Oh, what? Come on.
Yes.
Nick, you get lots of joy out of little things, don't you?
Yes, I do. I very much do.
Alright, I think I just need to not touch it. So, now I thought about like dyeing this water, but then when I splash it on things, that will be bad. So we're just gonna need to like deal with it being not dyed. So, three-dimensional shapes, right? Volume. You didn't have to go to the bathroom, now you do.
Yeah, kinda.
So, I got my cube filled up here. Right? Full of water. Now, I'm going to try, let's see if this works, and build up a little stand so you guys can see what I'm doing.
It's gonna fall.
Wait.
With your pessimistic attitude,
Wait, you wanna...
I am recording. I want to make that go away. You're right, though. Precarious? I like precarious. All right, there we go. So, we're going to deal with three-dimensional shapes today, and they're related other shapes. So when we talk about related other shapes, what I mean is we can take a cube and turn it into a pyramid by just taking the same length and widths and then just go to one point instead of coming straight up. Now I want you to make a prediction. How does the volume of this pyramid that has the same length, width, and height relate to the volume of the cube?
No. Well, maybe.
Yep, of course. Some water on the floor. So I've now, hopefully you know the word displacement. I've now created displacement. I have displaced a pyramid worth of water, right? So that when I take this out, there's a pyramid worth of water displaced, right? Because it's full when I shove the pyramid in. Does that look like half?
No, that's like a third.
That does not look like half. We can
You
move.
wasn't half. I was correct.
Cool it, Nick. Here we go. There we go. So that's definitely not half. Well, I got an idea. What if we start measuring in pyramids?
1 pyramid, 2 pyramids.
So we've now displaced or taken out 2 pyramids worth of water, right? So we're still going.
2 pyramids.
Nice voice crack. Puberty's fun.
No, I'm just measuring.
So 3. Exactly 3.
Well,
So guys,
more or less.
it takes 3, mathematically exactly, it takes 3 pyramids to equal the related cube. Or you can say 1 cube is the volume of 3 pyramids. Now wait, same question. Same question, but related triangular pyramid. How will the related triangular pyramid compare to the volume of the cube? Well, I gotta take a moment. I gotta reset some water. Am I supposed to make a mess in the math room? No, I wish they gave me a science classroom. No, I'm joking. What's your question?
So, in here, does that now calculate the volume of a pyramid by
Pyramids.
the volume of its
Cube?
corresponding
Yeah.
square?
And actually, it's corresponding rectangular because not everything even has to be a cube. So yes.
Look at, base or width, height, and
Yeah, your 3 dimensions, length, width, height, whatever you call them.
height, and then you divide by 3.
So now, sorry, I'm not so built up. I wonder if you guys can see through this. Yeah, you kind of can. Now, let's displace. Yeah, the water's dirtier now. So we've now displaced the triangular pyramid worth.
It's about half, yeah.
Well, if you want to check, is it half?
It's not exactly.
Okay, well, math doesn't work perfect in the real world. So the reason it's not exactly is actually the thickness of the plastic. This is a fun moment to talk about the fact that this thickness of the plastic actually stops it from being able to displace in actual half. So we would have the volume of the base plastic left over by accident twice, right? Because it would do it twice. All right, so moving on from cube. So related triangular prism, half. Related pyramid, a third, right?
What about
Every year that I do this, I break things more and more.
Cylinder.
You want to open that cabinet and look in the top shelf? So, Nick, chill a little bit, man. Because I don't feel great, and I'm still trying to do this even though I don't feel great. Yes, towel. That is why I have a towel here.
We'll just focus on the scene about cylinders.
Nick, can you spend 60 seconds not talking? So, what I want you to do is think about how the cube... Thank you very much. I'm just going to throw it on the ground. Use it like a mop. This is just an old towel. How the cube and... Well, I'm afraid I'm going to slip, so that's why I'm doing that. Today would be the day that I would forget and slip. So, the pyramid, unlike the cube, instead of going straight up from its base, goes up to one single point. The cone does the same thing, right? Instead of going straight up from its base, we go up to a single point in our 3-dimension. Actually, it doesn't matter if this point is in the middle or if this point is pulled off to a side. Same thing with a pyramid. Guys, pyramids don't have to be regular, meaning like the point is in the middle. A pyramid can be like to one side. Like if the Egyptians had made one side of the pyramid straight up and made it like a ski slope, kind of cool. Would have been like real fun during the winters in Egypt, right? Does it snow in Egypt? I'm pretty sure. I'm not sure. So, predictions? Do you think a third or a half? So, 1 volume displaced definitely not half, right? We can see from this. So let's try our testing method. Let's make sure we displace. Okay, that actually gets stuck if you do it perfectly. If you do it perfect, here's the real fun thing. I'm totally going to mess this up. You can actually flip it over, and it holds tight because your volume is trapped. So then, I know, because there was paper down in this tub. So now, one full cone, and actually, what I want you to realize here, every ice cream place selling you your ice cream in a cone versus a cup is ripping you off. Now, they know how much ice cream they want to give you, but think about it. If you had the choice of a cup or the same size cone, the cone's going to give you only a third of your ice cream. Rip off. Huh? Okay, yeah, but normally they build the cup up too. Well, it depends where I get. Now we're arguing the semantics of how do places scoop their ice cream. This is why places have started to do ice cream by weight. This is why places have started to do ice cream by weight. Now, the only last thing I need you guys to see is these relationships hold true no matter what. Hexagon. Hexagonal prism. Hexagonal pyramid. Right? We go from the full three-dimensional prism, and we can displace a pyramid of water. That's one pyramid taken out, right? What is left will be two more pyramids. It holds true for any prism and its related pyramid, or cylinder and its related cone. Callie? Yeah, on the side. Yeah. Yep. Adam? I feel like every comment now is going to be about ice cream since you started.
One could argue that with the cone, in the boulder, like filling it up, you could argue that with the cone, you're trading out the extra ice cream for the cone itself.
Okay, yeah, I mean, that is a good argument. So I'm going to stop my recording here because now we're just talking about ice cream.